So what we're gonna do is we're gonna talk about all the stuff. And yesterday we already go over some already, but I'm just gonna briefly go through and I color code everything for you, so that way you can see what is the difference between two. So we're gonna start with the stuff we already know, and we're gonna start with 0 degree, 180 degrees, and 360 degrees. And this is 90. This is 270. Everybody should have no problem here. We also talk about this unit circle is a very small circle. They just blew up very big. It's just has a unit. I mean, unit circle means 1 unit radius on the Cartesian coordinates. So that makes this one is 1, 0. This one's 0, 1. This is a coordinate. Okay, this is a coordinate. So it's basically, it's like this. It's going to be like something like, it's normal Cartesian coordinate. This is the circle. It's so small that blew up is so big. So there's a -1, 0. And there's a 0, -1. Liliana, do you have that sheet? You do?
Oh, it's good. Is there a way you can make it up? Is there a way you can make it bigger?
Oh, yes, my bad. Let me do that here. Is that better?
Yeah.
Thank you. So that's 0, 90 degree, 180 degree, and 270 degree, 360 degree. Now I'm going to color code everything because all the color is going to relate it to each other. So we're going to talk about this. So between 0 to 90 is going to be 45 degrees because that's a halfway. And so each of this is going to cost you 45 degrees. So therefore is next one's going to be what? What is the angle here? 135, good. So don't look at it. Don't look at what you have yesterday. You should be able to read that and you should be able to get it. This 135. And this one is late. 225, very good. And Emil, this one. 315, good. So 315. And I'm going to color code the other one. So Zenobia, do you know what's here? What? 38? 38 or 30? Is good. Okay. Remember, this is 90 degrees, right? But you break up this 3 sections. 1, 2. It's cut at 3 equal signs. So 90 divided by 3 is 30. Okay, there is no like there's not gonna be an angle with a 38. Usually I'll pretty much like a whole number, or not whole number, but it's like either end up with zeros or 5. Is that okay? Okay. So what do you think this angle is going to be? Zenobia? No? Ileana? 150 is good. Do you understand why it's 150? Because this opening is 30 degrees. You're gonna track it backwards. You're gonna go back. It's 150. Is that okay? Okay. Now, what do you think this one is? It's going forward. So what do you think it is? Yes. So now you're doing good. So now I won't bother you anymore. Okay. So here, Malin. 330. That's good because you can subtract 30. And I'm gonna go with this part. This part is actually 2 spaces. So you see this is 1 space 30 degrees. The second space equal space is gonna be double that. So it's gonna be 60. Does that make sense? Okay. Yasil, what's this one here? Good, 120, good. Austin, what's gonna be here? 240, good. And Vincent, what's gonna be here? 300. That's good. So we finish all the angles. So if you realize that 30 and 150, they all have a reference angle of 30. Because reference angle only between 0 and 90. And because 30 have same characteristic as a 150. I'm going to talk about why they have same characteristic in a second. Let's talk about radians. If I did a radian, this one's going to be 0. This should be black, sorry. So here it's going to be 0. And here is pi, and here's 2 pi. Any questions here? Okay. What happened on the top? Slate? Pi over 2, good. We already talked about this yesterday. And what happened on the bottom, Vincent? 3 pi over 2, good. So it's going to be 3 pi over 2. Does anybody have any questions so far? No? Okay, you already done this before. I'm just review. What happened here? I'm going to go to here. Does anybody know what is this one here? Let's go with, yes, pi over 4. Okay. Now, what happened here? Let's say, yes, you don't know. 3 pi over 4. That's very awesome. How do you know that's 3 pi over 4, by the way? How do you know that's 3 pi over 4? Yes.
You could do 5 divided by 180.
Okay, that's a good, but that's kind of hard to calculate without things. Slate?
So you can do, since pi for 180, so you can do 4 pi over 4,
Mhm.
and then subtract that with pi over 4, and then you get 3 pi over 4.
So remember, pi is also 4 pi over 4. Like 1 pi over 1, 4 pi over 4, right? You can go backward because this opening 45 degree, going backward 45 degrees, so it's going to be 3 pi over 4. Good job, Slate. Zenobia, can you tell me what happened? Same idea as last time? Using this to help you? Give it a try. It's okay. It's okay to be wrong. Maybe you're right. You never know. Huh? What'd you say? Yeah, it is over 4. What is over 4? Almost. There you go. 5 pi over 4. And do you realize that if I'm going back here, it's subtract pi over 4. So 4 pi over 4 subtract pi over 4 is 3 pi over 4. This one going forward is just going to be pi over 4 plus 4 pi over 4 is equal to 5 pi over 4. Does that make sense? Okay. How about this one? Vincent? 7 pi over 4 is good. So if you realize all the blue one is always over 4, and it's all in between the things. Okay, now let's go to 30 degrees. 30 degree, asinine, what is 30 degree? 5 over 6. And this, let's go with Emil. Does anybody have any question why that 5 pi over 6 is? Zenobia, you understand? You think about this, this is also equal to 6 pi over 6 because 6 divided by 6 is pi. So pi can be 4 pi over 4, 6 pi over 6. You can actually go back exactly same opening, which is going back here. So going back here. So it'd be 6 pi over 6, subtract 5 pi over 6. Does that make sense? Okay, so what do you think on this? Instead of subtract, what do? You add, so what are you going to get? What do you think is over what? There you go. See, you got it. Elena, can you help me with this part? Yes. 11 pi over 6. And then you got all the pi over 6. See, all of this location is always pi over 6. Okay, now last one, Austin, this part on the corner here,
Pi over 3.
pi over 3, and that's green. And sorry, this is pi over 3. And Alan, can you tell me here?
42 pi over 3.
Perfect. And Asnai here? 4 pi over 3, good. And 300 degrees, let's say Yaso. 5 over 3. So it's like you see that's the number. Okay, so far this is all what we did yesterday. We also did this part, which is we talk about the blue triangles. So we're talking about this, and we connect this point, we connect this point, and we connect this point, and we connect this point, and then we connect this point, and then we connect this point here. Okay, so we have a 4 different triangle. They are exact same sizes because they are 45 degrees. And this is 90, and this is 45. So they are 45, 45, 90 triangle. And so what I'm going to tell you is on SAT, so we're going to talk about 3 things on SAT you have to worry about just on this particular place. So on SAT, you had to be able to convert the degree to radian and radian to degrees. And you're going to see that. And this is also on ACT as well. So SAT, ACT, you're going to have this. But both SAT and ACT have a special right triangle, which is called isosceles right. Okay, so that means this is right, this is 45 degree, this is 45 degree. Does anybody know the ratio for 45, 45, 90? What?
So like X, right? Let's see it.
On where? X square root 2 where? Hypotenuse, good. X times square root 2. And what about the other two sides? X and X. So this is on the first page of SAT. They usually give it to you. You don't have to memorize it, but for me, I think it's better for you to memorize it because you don't have to flip back to the first page. Now, with the same triangle, let's say if I have a same triangle here, and I say, hey, copy, paste. I have exact same triangle here. And if I say this side is 6, what does make this side? And what does make this side? Slate?
The bottom one's 6. Hypotenuse is
6 radical 2, which just makes sense because you got 6. This is isosceles, right? This is congruent. This is congruent. And the other side just 6 times square root 2 because this is x times square root 2. Now, same thing on the other side. On SAT, you're going to see something like this. And this is 45. This is 45. And if this side is 10, will be the x and will be the y. I know you know. Yes, Asnai.
2.
By root 2, because you're going to take this equal to this ratio. Does that make sense? So you're going to get 10 equal to x times square root 2. And then x equal to 10 over square root 2. Now what he did, he actually did it in his head. This is square root 2 over square root 2. And that's actually equal to 10 square root 2 over 2. Rationalize, it's going to be 5 square root 2. So therefore, this is 5 square root 2. And this is 5 square root 2. Does that make sense? And if you think about it, if this side is 5 square root 2, and if I get to the hypotenuse, basically times square root 2 again. So 5 square root 2 times square root 2 is going to be 5 times 2. 5 times 2 is 10, which is completely makes sense. Okay, so here's my question. What if, we already did this yesterday, I think. What if this is a 45, this is a 45, and this is 1? then we're gonna set this one equal to that, right? Does that make sense? And I evaluate it, and I rationalize it. So it'll be square root 2 over 2. So therefore, this side is square root 2 over 2, square root 2 over 2. So what we did is we got this side is square root 2, and this is square root 2 over 2. So that means it becomes a coordinate. This one is going to be square root 2, and this is square root 2. Are you confused? Are you doing okay? This part is going to be negative square root 2 because of the x on the negative side. And this is square root 2 over 2. And this is both negative. And this is one positive and one negative. The y is going to be negative. So you think about on unit circle, this one's going to be plus plus. And this one is negative plus. And the plus negative. Oh, sorry, negative negative. And this is a positive negative. Okay. Are we okay here? And you're going to be like, how is this related to SAT? You know what? SAT is going to give a question like this. So I'm going to show you what an SAT question looks like. It's going to be a circle. And it's going to be like this. There is a square inside a circle. And they will say, hey, can you find the area of the square? So find area of square where circle has radius of 10. So this is a good SAT question. You say, wait, how do I have a radius? But how is that related to the things that we just teach? So if this is on SAT, how would you do it? Austin, I know you practice a lot of SAT in the summer. That's the time you can show off your skill. Yes, Malin?
The radius would split this square in half diagonally. So then if you make it into 4 triangles, the sides on the inside would equal to 5.
So are you talking about this length right here?
Yeah.
What is this size going to be? How long is this side? 20. Good, because radius is 10, right? So this side is 20. Good job. So this side is 20. And okay. So what is that going to do with 45, 45, 90 triangle?
Oh,
Yes, Vincent?
you divided it by wait. You divided by root 2, right?
Yep. Remember, this is they cut off exactly, right? This is 90, right? So that's going to be 45, 45, 90, and this is 20. 20 is equal to x times square root 2. So x equal to 20 over root 2. So this is 20 over root 2. They can even ask you the side. Now, if I know one side of a square, so area is equal to 20 root 2 times 20 root 2. So that's equal to 400 over 2. That's equal to 200. There you go. SAT question for you. Got it? Is it hard? No. But you got to learn how do they ask you a question. This is how you learn. Okay. I coach you this all the time, so I know. So with that being said, we finished with 45 degree. We just have to do one more, believe it or not. So we're going to do the one that's red. So I'm going to talk about this one. I call this butterfly as a fat butterfly. I'm fat shaming a butterfly. Cancel me. Okay, so there is a wider version of butterfly of this. The other one is like a medium size, and there's actually a skinny butterfly, and we'll show you in a second. So this one is going to be right here. Now, does anybody know the ratio for 30, 60, 90? 30, 60, 90. So let's say this is 30, 60, 90. So this is 30, 60, 90. And I'm going to copy here. And I'm going to paste here. I'm going to paste here. Okay. So what doesn't anybody know the ratio? Does anybody know the ratio? Nobody? Everybody? Geometry, don't remember? Yes, Emil?
1 root 3, 2.
What?
1 root 3 and 2.
Okay, so I'm going to do it in terms of x. So this is x, this is 2x, and this is x square root 3. So I just replace that 1 as x. And I think that's easier to remember. So therefore, if what happened if this is a 10? What is this length here, and what is this length here? Pi and 5 root 3. Good. Okay, now I'm going to give you a hard one. What if this side is 8? And what's the other two sides? X could be what? I think that's probably correct. So I'm going to say x square root 3 equal to 8. And x equal to 8 over square root 3. And you multiply by square root 3 over square root 3. So that's equal to 8 square root 3 over 3. So it's actually equal to 8 square root 3 over 3. And the other side here is going to be 16 square root 3 over 3. Double. Just double the coefficient in the front. Am I going too fast? I'm going to do the last one. Wait, what's the last one? Paste. Okay, so the last one here, what if this one is 1? This side is going to become what? 1/2. And what about this side? Yep, root 3 over 2. Turn out this is one of the special triangles. So this is root 3 over 2. Sorry, I'm going to use a different color pen. So root 3 over 2, this is 1/2. So therefore it's going to be root 3 over 2. And this is 1/2. In that case, negative square root 3 over 2, 1/2. Negative square root 3 over 2, negative half. And square root 3 over 2, negative 1/2. Am I going too fast? Because this is 1, right? Emil, do you understand? You look at me like, how'd you get that?
Don't you get the same answer if you just use the base one? If you just use the one I told you, the 1, 2, and 3?
You can. I want to show you in term ratio, and I want people to memorize the ratio. But the way you memorize, just memorize the number, which is fine. Okay. So what happened with this skinning triangle right here? Right? What's the difference between this triangle and that triangle? I'm going to talk about what triangle. Oh, this butterfly right here. And this is right here. And this is right here. Oops. And that's right here. And this is right here. Okay, so there's 3 different versions of butterfly. What happened is the relationship between the green and red? Yes, Madeline? They both are 30, 60, 90. But what's the difference between red and green? Yes. The x and y is flipped. They switch. Very good. So this is going to be 1/2. Right, this is 1/2. And this is square root 3 over 2. And it's a negative 1/2 square root 3 over 2. And this is negative 1/2. Negative square root 3 over 2. And this is 1/2 square root 3 over 2. There you go. You complete a unit circle. On your test, you don't have to worry about positive and negative. Basically, it's all student take calculus. I think Mr. Chaparral talk about that. No. No. Okay. Never mind. Basically, all the function with sines. Yes. Right. Sine, cosecant, and tangent. Sine, cosecant. So all student take calculus. Sorry, they're all positive. So all trig functions. So all trig function is positive and none of them are negative. So all student take calculus. This is S. That means sine. Sine and cosecant function is going to be positive because sine is a y. So sine is going to be positive. So it's all student take calculus. So take calculus. And the reason why it's S right here, S is all sine function and cosine function is going to be positive. Sine function and cosecant function is going to be positive. Cosine is going to be negative here. And this one's only tangent take. So tangent is positive because it got negative over negative because tangent is y over x. And this one is cosine because on the right side, the x is positive, therefore cosine is positive. But you don't have to know that. So I don't test you positive, negative. I just want you to know that depends on what your teacher taught. So this is a unit circle to you. Huh? Second quadrant is sine and the cosecant. It's positive. Rest of it's negative. But it doesn't matter. I'm not going to test that tomorrow. But I'm going to test this tomorrow. So you got to pay attention here. We almost get through. So this is a 1 over cosecant of theta. So the way I think about it is if I start with S, I always end up with a C in terms of reciprocal. If I start with C, I should end up with an S. But it's not 1 over sine, so it's going to 1 over secant. And you see that SCCS is going to happen on the other side too. So if you start with C, it should be 1 over sine. And this is a 1 over cosine. And I always write down theta because theta is the argument of the trig function. This is a 1 over cotangent theta and a 1 over tangent theta. And this is going to be all. Am I going too fast? This is something you learned last year. Do you know what's tangents equal to on the quotient identity? Yeah. Have you seen this meme? I don't know where's the meme go. So tangent. Like my favorite one is this one's pretty funny. Singering and cosingering. But the one I thought was really funny is where they are. Is this one? It's not even summer. I already have a 10. I know, it's so dumb. I almost want to get a tattoo because I like it so much. Okay, so sine over cosine. And I like this one. This one's actually really good. And there's a cosine over sine. Because they're reciprocal. This is a very popular one. Very, very important. Easy point. Okay. I'm going to show you a, there was a geometry. I know this is like a very fast course of A, B, and C in this data. And A is known as opposite, right? Do you remember that? And B is adjacent. Do you remember that? C is hypotenuse. Do you remember that? And there was a SOHCAHTOA. SOHCAHTOA, which is sine equal to opposite over hypotenuse. So you'd say, hey, Pythagorean identity, I know, but it has nothing to do with Pythagorean identity here. But how do we get it from there? A squared plus B squared equal to C squared. And if I take this function, if I divide it by everything by C squared, something magical happened. So that's going to be A over C. Well, A over C is also, I'm going to rename that A. A is opposite over a hypotenuse square plus, what's a B over C? Adjacent over hypotenuse. And that's equal to 1. Does that make sense or no? I just replaced that A is opposite hypotenuse. What do we know is opposite over hypotenuse? Sine. Sine squared theta plus cosine squared theta is equal to 1. That's it. That becomes the first trigonometry Pythagorean identity that you need to know. Sine squared theta plus cosine squared theta is equal to 1. And some student says, can I don't write a theta? No, you have to write a theta. Theta is like its argument. Okay, so you have to have like, you have to have something in there. If you program, if you don't have argument, that doesn't make sense. Computer is not gonna compile. And also one more thing I want you to know the notation. If I have sine squared theta, that just means sine theta square, but that does not mean sine theta square. So the last one does not equal to because that square only applied to theta, but not applied to the whole thing. But the first two is in between, that means sine squared theta or sine theta parentheses square. That means the exact same thing. Doesn't equal the last one. Please don't write down sine theta square tomorrow. You write down sine squared theta. And I'm going to show you, take this function, you can derive. So they say memorize A. I told you to memorize. I didn't ask you to prove it, but this is how you prove it. You don't need to prove it. You just had to memorize sine squared plus cosine squared equal to 1. In Shaparro's class, you should have already this memorized, right? Emil's like, yeah, maybe. Okay, you should have this memorized. And what you're going to do is you're going to take this function and you divide it by everything by sine squared. So I take this function and I divide it by sine squared. Guess what's going to happen? What is that equal to? Sine squared over sine squared is what? 1? Good. So 1 plus, what's cosine over sine? Cotan. And what's 1 over sine? Cosecant. And you just come up with a second identity, a Pythagorean identity. And you get it without memorizing nothing. I'm going to do the same thing, but this time I'm going to divide it by what? Yeah, you guys are very smart. Cosine squared theta over cosine squared theta. And this becomes a new identity is tangent squared theta plus 1 is equal to secant squared theta. What time we get off? 28, right? Okay, so we got another time. Any questions so far? Am I going too fast? You should get half the point already. This is all easy point. You can get this all day long. Not memorization. You remember first two, you get applied to number 3. You just have to memorize one more thing. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 more identity you need to know. Now there are a lot more identity on this, on trig, but this is the most important one. This is the one that's gonna matter more than other. Sum and difference, you're gonna use, not gonna use it ever in calculus, but it's good to have it because that's how you get double angle identity. So I had to teach it. In pre-calculus, I always teach it. This is the most pain in the butt one, I think. But I remember this acronym. I'm gonna write down the acronym. So this acronym is SINE. It's a SMS. That's the acronym. And if you don't know what that means, the S stands for sine. The M stands for mixed group. And this stands for same sign. Okay, and that's for this and this, for A and B. What do I mean by sine? Well, sine's matching this, so that's just sine. So that means we had to use mixed group. And the way to think about mixed group is like this: sine, cosine. And this is one group. The second group is going to be cosine, sine. Now, if you realize I did not do cosine, cosine, sine, sine, I do sine, cosine, and then cosine, sine. I even changed the order around. And I'm going to place that A and B here. I'm going to place that A and B here. And I'm going to use the same sign as before. The before has a plus sign, so I'm going to just do plus. So you just got a first sum and difference formula by using SMS. Sign, mixed group, same sign. So if I ask you to memorize, I will find an easy way for you to memorize. Sometimes it may not be appropriate though. But some weird thing is most kids remember inappropriate stuff. But this one's okay. Okay. The next one, we can practice again. So this is sine. Then we know it's mixed group. Practice, write down mixed group. Sine, cosine, cosine, sine. And just write down the angle separately. A, B, A, B. And this one's going to be same signs before, so it's minus. So we're going to talk about the different one. So it's cosine. CSO. So this is a cosine. This is an acronym for that. This is same group. And the group has to start with the same centric function. This is opposite sign. Okay, so it's going to be cosine, cosine, sine, sine. See the same group. The cosine's group with cosine, sine's group with sine. It's going to happen again. And I'm just going to put this thing in. A, B, A, B, A, B, A, B. Now the sign's going to be opposite than before. So I start with a plus. I should end up with a negative. And I start with negative. I should end up with positive. We got 6 more to go. Almost there. Sine 2 data. Some people says, hey, 2 data. What is 2x equal to? What's another way to write down 2x is equal to? You are a genius. It's x plus x. It was not a hard question. So what you're going to do is you're going to place this as data and data. And then you will have data here, data here, data here, data here. And what's nice thing is this. Sine of 2 data is equal to sine of data plus data. And that's equal to, again, I'm going to practice the sine, cosine, cosine, sine. So instead of write down A, B, I'm going to write down data, 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 data. And this is plus. Now, if you pay attention, this is associated property because cosine, sine, sine, and cosine, they are multiply each other. So that's actually a like term. And usually I told students to memorize this, but 2 sine data, cosine data is actually not too bad of memorization. But if you don't want to memorize, if you memorize CSO or SMS, then you just have to apply it. What do you think cosine 2 data is? Which equation I'll be using? Yep, cosine, cosine, sine, sine. Really good. So can that be cosine squared data minus sine squared data? Does that make sense? It's just basically data plus data. So let's just plug in all the data there. It becomes cosine data times cosine data minus sine data minus sine data. We finish a 2 major one. This is what I told students that's most important one that I will always use on a calculus test. I won't use sum and difference that much. I will use Pythagorean a lot, but I will use sine 2 data and cosine 2 data a lot too, depending on which question. Now let's talk about the other two. The other two, we kind of actually have to we had to be resourceful. So we're going to take this and we're going to say, hey, let's move the cosine to the other side. Oh, sorry, let me do this. So I'm going to do cosine square. And this is sine square. And if I move the sine square to the other side, that's equal to 1 minus sine square. And that's equal to 1 minus cosine square. So that becomes a true statement. If it's a true statement, I can use that to substitute into something. So what I'm going to do is I'm going to take this. Here, I don't like this one. I want everything uniform in a symmetric function. So what I'm going to do is I'm going to say 1 minus sine square. Because I know cosine square can be replaced with 1 minus sine square. And I'm going to say minus sine square theta. And remember, this is a cosine 2 theta. Those actually end up to 1 minus 2 sine square theta. And that's it. You just come up with another one. It's like one pop up another one. Oh, sorry, I mean color code this part a little bit different. So that way that we know that's the things that doesn't change. So instead of replace the cosine, I'm going to replace the sine. So I'm going to change the cosine to the black and the minus. And instead of that, I'm going to say it's 1 minus cosine square. And if you do that, it's going to distribute a negative sine 2, negative sine is going to distribute. So that end up to be 2 cosine squared theta minus 1. In trigonometry, they are pretty much symmetrical. And if you see that symmetries between two things, they just change the order and the two arrangements different, but it's very, very symmetrical. We got 2 more to go. And we're done. We're gonna finish on time for the first day. You're like, this is like crazy. We crammed like 2 weeks of trigonometry in 1 day. Yeah, I had to do that. Okay, so sine square. I'm gonna show you the sine square is related to this one. Now I'm gonna rewrite that identity right here so that way you can see it. So the identity is gonna be cosine 2 theta is equal to 1 minus 2 sine squared theta, and that's true statement. Cosine 2 theta is equal to 2 cosine squared theta minus 1. Okay, hold on, let me finish. I'll write you pass if you need it. So I'm gonna take this, I'm gonna solve for it. I'm gonna solve for that. So I'm gonna solve an easy one. I'm gonna do this one. I'm gonna take this one and then move the 1 over, right? So it'll be 1 plus cosine 2 theta equal to 2 cosine squared theta, and I'm gonna divide by 2 on both sides. So that's gonna be 1 plus sine 2 theta. Oh, sorry, 1 plus cosine. It's the only thing I screwed up. 1 plus cosine 2 theta over 2. And remember, they are symmetrical. You can actually do the same thing. You can move this to the other side and move this to this side and divide it by 2. And remember, they are symmetrical, so it's going to be 1 minus cosine 2 theta over 2. And there you go. Those are all the power reducing and everything. So we just memorize, we just know how this is. And I'll see you tomorrow. Your homework is to memorize everything. Okay, last part, if you are interested, it's going to look like this. Well, I take this, I move this to the right side. So it's going to be 2 sine squared theta plus cosine of 2 theta equal to 1. And I move this to the other side, so it'll be 2 sine squared theta equal to 1 minus cosine 2 theta. And I'm going to divide it by 2. So it'll be sine squared theta is equal to 1 minus cosine 2 theta over 2. So this is where they come from. So there's like a 1.5 week of material in 1 day. I had to find a way to cut down the time, so I concise everything into like very, very short lessons.
This is gonna be on YouTube.
Yeah.
It's what was your YouTube again?
DJYUF the youtube.com/DJYUF. I'll post on the thing.